All right, my favorite problems. I love sketching graphs. Sketch the graph of each function and supply the requested information. Show all the important components of the graph, and you should know what that is at this point. So like all intercepts, all asymptotes, all holes, pretty much sums it up. So what do we do? Domain, it's a polynomial, so our domain is going to be all real numbers. So I will use set builder notation to say x is in the set of all real numbers, satisfies my domain. Range, it's a polynomial, so again, all real numbers, so y is in the set of all real numbers. Zeros are my x-intercepts, so I'll have an x-intercept at -4, 0 from the first factor, 0, 0 from my second factor, and 3, 0 from my third factor. So notice I have a point at 0, 0, so that is my y-intercept as well. So let's sketch this thing now. Sketch all those pieces in. X plus 4, so 1, 2, 3, 4. And let's plot a point x, giving us an x-intercept at 0. So let's plot a point, and then -3 giving us an x-intercept at +3. So we will plot a point. The x-intercept at 3 will bounce because the multiplicity is even. The x-intercept at 0 will bounce because the multiplicity is even. And the x-intercept at -4 will cross because the multiplicity is odd. Now, this is a positive function, which means my graph will be going up to the right. So my end behavior is up to the right. So I can use that to start. It's up. I come down to that x-intercept, and I have to bounce because of the multiplicity. I have to curve back down. I have to bounce again because of that multiplicity. And then I have to cross through because of the multiplicity there. And that's going to be my graph. Now, I can make it look better since that is cubed and that is to the fourth. That does change how it looks at the intercepts. The fact that that first one is fourth is a fourth power means it's going to be like really steep and then kind of like flatten out severely there and bounce up, and then it'll come up versus this one, which will kind of like smoothly bounce a little more. I'm trying to show that to be a little flatter. It didn't really work. But then, because that's cubed there, it's going to come down and it's going to kind of like squiggle a little bit at that x-intercept. I didn't do it justice, but it does look something like that. All of the important pieces are there.